Hello, dear students. Welcome back to the second lecture of the lecture series on Machine Design 2. First of all, I would like to remind you that I have created a WhatsApp group invitation link separately for Section A and Section B. Most of you have already joined that group. Those who fail to do so are requested to join their respective WhatsApp group at the earliest. Through that group, you can connect to me and Professor Naushad Alam easily. You will find the WhatsApp group invitation links at the last slide of first lecture, which can be downloaded from my webpage. I will be uploading videos as well as the presentation which I will be using in my video on my webpage. You can find the link to my webpage in the description section of this video. In case of any difficulty, feel free to contact me. Secondly, as I posted on your class WhatsApp group, I would like all of you to activate your myamu.ac.in account, your email accounts which is basically given to you by the university. I have already created separate classes for the respective section on Google Classroom and have added your myamu.ac.in email ID in that. So for you to attend the online classes, you have to use the same account. However, it came to my knowledge that some of you are not able to activate your account. I have escalated this issue to the chairman of Mechanical Engineering Department, to which he suggested you contact the controller's office. You can find the email ID to contact the controller's office in the description section of this video. Anyways, I hope almost all of you must have already activated this account. I will be taking your questions during class time as per the class timetable. You can go through my video lectures and presentation uploaded on my webpage, and in case you have any doubt or any query or any part of the video needs further explanation, you can ask that doubt or you can ask me to further explain that part in the online class or the live class, which will be held on Google Meet. I will share the Google Meet link with you on your WhatsApp group. Further, I will be uploading the assignments on the Google Classroom, and you will have to submit the assignment using the same platform. Please avoid sending the assignments to me through email. It will be easy for me to collect all your assignments through Google Classroom. Now, coming back to the course, in the previous lecture, I have given you the syllabus overview, explained all the course objectives and the respective course outcome for all the units. I would like to remind you once again that I will be taking first unit and the last unit, and the rest of the 2 units will be taken by Professor Naushad Alam. In this lecture, I will start with the first unit of this course, which is welded joints, clutches and brakes. I will be explaining different types of joints in this lecture and different types of welded connections and their application. So before we start with the welded joints, let's see how many types of joints are there. So as you can see in this slide, there are three different types of joints. The first one is temporary joint. The second one is a semi-permanent joint. And the third one is a permanent joint. Now first of all, let's talk about a temporary joint. A temporary joint is a joint that can be dismantled without breaking the assembled part. So you can basically, in case of this temporary joint, you can do the assembly and disassembly any number of times without breaking the components. Temporary joining is beneficial where frequent assembly and disassembly are required. An example of the temporary joint is shown in this figure. This is an example of a temporary joint where your wheel, which is your first part, is attached to the car, which is your second part. So this is your first component, which is your wheel, and this is your second component, which is your car. So the joint, this type of joint is known as temporary joint because you can remove this wheel from the car any number of times without either breaking the wheel or the car. And with the help of these lug nuts and bolts, you can join or you can attach this wheel to the car. Now, an important point to note here is that in case of temporary joint, when you do the disassembly, your parts which were assembled does not get damaged, and neither the parts which are responsible for the assembly, for example the lug nuts and bolts in this case, they also does not get damaged. So you can reuse this lug nuts any number of times for assembly and disassembly. So as I told you earlier, that this type of joint is used where frequent assembly and disassembly is required. Now another type of joint is your semi-permanent joint. This is your semi-permanent joint. Now again, in case of semi-permanent joint, you can do the assembly and disassembly without breaking the components, but this semi-permanent joint is different from temporary joint in a way that in case of semi-permanent joint, the parts responsible for the assembly gets damaged in case of disassembly. Whereas in case of temporary joint, when you do the disassembly, the parts which was responsible for the assembly, for example the lug nuts and bolts in case of a wheel and a car, they are also intact. They also doesn't get damaged. Whereas in case of semi-permanent joint, the parts responsible for the assembly gets damaged. So this is a major difference between semi-permanent and temporary joint. Now an example of the semi-permanent joint is rivets. In this figure you can see a part of the bridge where different components of the bridge are assembled together with the help of rivets. These are your rivets. All these protruding members are your rivets. Okay, so this is an example of a semi-permanent joint where you have assembled two components. This is your first component and this is your second component with the help of rivets. Now again, as I told you, you can do disassembly in this, but these rivets which are responsible for the assembly, they will get damaged, and when you will reassemble these two components, you will need a new rivet. That's why in this way this semi-permanent joint is different from the temporary joint. Now the third type of joint is your permanent joint. This is your permanent joint. A permanent joint can be dismantled, a permanent joint cannot be dismantled without breaking the parts. So if you have joined two parts together with the help of a permanent joint and you try to disassemble them, you have to break those parts in order to disassemble them. So a permanent joining is beneficial only where the joint is intended to where the joint is intended to stay for longer periods. Okay, so the permanent joint is used where the joint is intended to stay for longer period. An example of a permanent joint is your welded connection. As you can see in this figure, this is an example of a permanent connection. Over here the welding has been done. Again, this is your part number 1 and this is your part number 2. Now they have been connected together with the help of a welded joint, and in case you need to make the disassembly because of some reason, you have to break both of these parts, and then these two parts cannot be reused for the reassembly. So this is a major disadvantage of the permanent joint, that you cannot do the disassembly, and in case you have to do the disassembly, you will have to use new parts for a new assembly. So your permanent joints are always used where the disassembly is not required. So I have given you an example for the permanent joint as a welded connection, and in this unit we will study in detail about this permanent joint or the welded connection. We will see different types of welded joints or welded connections, and then we will try to see the design and analysis procedure of different types of welded joints subjected to different types of loads. But before that, let's see what are the advantages. This slide is basically giving you the definition of the welded joint. So welded joint can be defined as the process of joining metallic parts by heating to a suitable temperature with or without the application of pressure. Now it is important to note that the welded connections are very economical and efficient method for obtaining a permanent joint. Okay, mind it that it is an efficient and economical method for obtaining a permanent joint of metallic parts. Now let's see what are the advantages of welded joints over riveted joint. So as I told you in the previous slides, that your welded joint is a permanent joint and your riveted joint is a semi-permanent joint. So we will see some of the advantages of the welded joint, which is a permanent joint, over the riveted joint, which is a semi-permanent joint. The first advantage of the welded joint over riveted joint is that in case of riveted joints, you have to use the fish plate. Now I will show you what I mean by a fish plate. Fish plate is basically an additional plate which is required for the assembly of two components in case of semi-permanent or in case of riveted joints. So if you can see this plate which is over this structure, this plate, just a moment, this plate over here, or you can see in a bigger picture, this plate over here is known as fish plate. So in case of riveted joint, you always have to use a fish plate. Now talking about the fish plate, what basically is the disadvantage of using fish plate? Why we are considering this fish plate as a major disadvantage? Now the reason being, because of the addition of this fish plates all over the structure, the overall weight of the structure increases, and obviously the cost of the structure increases, and both the parameters are undesirable. Because the first one is the unwanted weight of the structure is going to increase, and the cost, because of the addition of the fish plate, the cost is also going to increase. So because of this fish plate, the cost as well as the weight of the structure is going to increase, which is not needed in case of welded joints. You do not need any fish plate in case of welded joint. You do not need any fish plate in case of welded joints. Now the second advantage of the welded joints over riveted joint is that the welded joints are completely leak proof and tight. You can see in this figure that your riveted joints are not completely tight or completely leak proof. Whereas in case of this figure, or in case of the welded joint, you can see that the welded joints are completely leak proof. So this is another advantage of the welded joints over riveted joints. Okay, now the third advantage of the welded joint over riveted joint is that they take less production time. So again, I'll refer to this figure. You can see that you have to rivet at all these points, at all these protruding members, you have to rivet. Whereas in order to join these two components with the help of welded connection, you only need to do welding at this this place. Okay, so a riveted joint is a time-taking process when compared to welded connections. Now the fourth advantage of the welded joint is that stress concentration in the riveted joints are very high. Now this is a this is a major disadvantage in case of riveted joint, and it is a major advantage in case of welded joint, that the stress concentration in case of riveted joints are very large. Again, I'll refer to this figure. You can see that in order to rivet at all these points, you have to first of all drill the hole. Now because of this hole, there will be stress concentration. At every point where you are going to drill the hole, there will be stress concentration in the vicinity of that hole. Now because of that stress concentration, the strength of the structure is going to decrease, which is the fifth advantage of the welded joints over riveted joint. Since there are no rivets to be attached in case of welded joints, therefore we do not need to drill any hole, and in the absence of hole, there is no stress concentration in case of welded joints, because of which the strength of a welded joint is very high as compared to a riveted joint. Now coming to the last advantage of the welded joint, sometimes it's difficult to rivet certain geometry, such as a circular pipe. Now if you see this figure of a welded joint and imagine to rivet this first component with the second component, it's very difficult. So in case of circular pipes, it's very difficult to rivet, but it's rather very easy to weld these two components. However, after telling all the advantages of the welded joints over riveted joints, it's also important to see the application of the joint which is to be used. So for example, if a frequent assembly and disassembly is required, then we cannot use welded joint despite of all the advantages. Okay, however, I have told you the major advantages of welded joints over riveted joint. Now since we have talked about the advantages, let's see what are the disadvantages of the welded joint. The first disadvantage of the welded joint is the poor damping property. Now in case of welded joints, we have very poor damping properties. Therefore, where the vibration levels are very high, we cannot use a welded connection. For example, in case of a bridge, we cannot use a welded connection to join two components of the bridge. Now the first reason is that the vibration levels at the bridge are very high, and since the welded connections have a very poor damping property, the joint may break. And the second reason is that the component of the bridge might need some part of the bridge might need a replacement in the long future. So that's why also we cannot use any permanent connection or permanent joint in case of bridge. Now the second advantage of the welded connection is that or sorry, the second disadvantage of the welded connection is that the inspection cost is very high. Now, obviously, when you have made any joint or if you have made any structure, the inspection would be there. Now, the inspection cost for riveted connections are comparatively very low, whereas the inspection cost for the welded connections are very high. Now, the third disadvantage of the welded connection is that the strength of the welded connection totally depends upon the skill of the worker. Now, for example, if I am going to weld any two components or any two structure, then obviously the strength of that structure will be much less than the same structure made by some skilled worker. So you yourself must have done welding in your freshman year, and you must have realized that this welded connections require a highly skilled worker in order for it to work properly. So this is again a disadvantage that not no that the strength. Now let's talk about the last disadvantage of the welded joint, which is residual stresses. Now these residual stresses are the bad elements. We don't want them. And what are residual stresses? Residual stresses are the stresses which are developed in a body or in any structure without the application of external stress. So this is basically a type of stress which is present inside the structure when there are no external forces acting on the body. Now they are developed inside a welded joint because of uneven heating and cooling. Because of this uneven heating and cooling, in the vicinity of the welded joint, there are residual stress. Now, what makes this residual stresses even more dangerous is that the magnitude of these residual stresses cannot be predicted with any degree of certainty. So suppose I have four identical plates and I'm going to make two different structures with them. I have to weld plate number 1 and 2 together, and I have to weld plate number 3 and 4 together. Now, since we cannot predict the magnitude of the residual stresses, so we cannot say in which structure the residual stresses are more. However, the idea is to minimize the residual stresses. So since we cannot predict the developed residual stresses in case of both the structure might be different even if your working conditions are same for both the structures. So this is one of the major disadvantages of the welded joint, and this is because of the uneven heating and cooling in the vicinity of the vicinity of the vent, which causes thermal distortion, resulting in the residual stress. Now, the good news is that we have some methods which will reduce the magnitude of the residual stresses. Here you can see that these are the two methods which reduces the magnitude of the residual stresses. The first method is preheating. Preheating of the weld area to retard cooling of the metal in the vicinity of the joint in the vicinity of the joint will reduce the residual stresses. So this is your first method. And the second method is the stress relieving of the weld area by using proper heat treatment such as normalizing and annealing. In case of preheating, what we do, we preheat the structure to be welded, or we preheat the plates to be welded before welding. And since the plates are preheated, the uneven cooling of the structure is reduced. Basically, there is no uneven cooling, which in turn reduces the magnitude of the residual stresses developed in that structure. The second method is your heat treatment. This is your first method and this is your second method. In this, we do normalizing or annealing in order to reduce the residual stress. The first method is your pre-welding method and the second method is your post-welding method. We do preheating. We use preheating to reduce the residual stresses before actually welding the structure, and we use heat treatment obviously after the welding of the structure. The results obtained from these two methods are shown. That is, they reduce the magnitude of the residual stresses. However, both these methods are completely different in a way they achieve this. Preheating can be treated as a precaution and heat treatment can be treated as a cure. Since preheating is done before the welding, that's why we are calling it precaution, and heat treatment is done after the welding. That's why we are calling it as a cure. Secondly, preheating, although both the methods are reducing the magnitude of the residual stresses, but preheating is actually eliminating the cause which is resulting into the development of residual stress. Okay, preheating is actually eliminating the cause which is resulting in the development of the residual stresses, whereas heat treatment is reducing the magnitude of actually developed residual stresses. Okay, so this is the major difference between the two. Although both of the methods are reducing the residual stresses, but the first one is eliminating the cause which is resulting in the development of residual stresses, and the second method, which is your heat treatment, is reducing the magnitude of the already developed residual stress. So these are the two methods which you can use in order to reduce the magnitude of the residual stresses. However, there is another method which you have already done in your freshman year in the manufacturing lab while doing the welding, and that method is known as hand sealing. It consists of hammering the weld along the length with the peen of the hammer while the joint is hot. Here, it is very important that you hammer along the length of the weld when the joint is hot. Once the joint is cold, this method will not work. So you have to hammer along the length of the weld with the peen of the hammer when the joint is hot. It not only reduces the residual stresses, but it also induces residual compressive stresses. Now, these residual compressive stresses are good components. On the contrary to the residual stresses, these residual compressive stresses are good components. The compressive stresses prevent the spreading of the fatigue crack and thus improve the fatigue strength of the joint. So these compressive stresses are actually they are actually preventing to spread the fatigue crack and hence increasing the fatigue strength of the joint. So these are the three different methods which can be used in order to reduce the residual stresses. However, the magnitude of the residual stresses cannot be zero, but they can be reduced to a significant. They can be reduced to a large amount by a large amount. Now let's talk about the different types of welded joints. There are two different types of welded joints. The first one is butt joint, and the second one is fillet joint. If you recall my first lecture, I have already told you what is a butt joint and a fillet joint. However, I will explain it once more. So, your butt joint is a joint when both the components are kept within a plane. If two components are kept in the same plane and the welding is done along the edge which is touching
basically when the welding is done along the edge, then that type of joint is known as butt joint. Now there are different types of butt joints. The first one is square butt. The second one is U butt. The third one is double V butt, and the last one is V joint with backing split. Now the selection of the type of butt joint totally depends upon the thickness of the plate and reliability. So as you move down this list, the thickness increases. Okay, the thickness of the plate increases, and so does reliability. Okay, so basically, as you move down the list, the thickness of the plate increases and the reliability also increases. So this image will show you different types of butt joints. In the first figure, you can see that plate number 1 and plate number 2 both are kept in the same place, and the welding is done along the edge adjoining both the plates. Both the plates. Now you can see in this figure that no machining is required for a square butt joint. We haven't done any machining before welding these two parts. So when the thickness of the plate is less than 5 mm, this is the thickness of the plate. This C. This is the thickness of the plate. It's called the thickness of C. When this thickness is less than 5 mm, then we use square butt joint, and since the edges are square with respect to the plate, you can see that the edges are square with respect to the plate. That's why this type of joint is known as square butt joint. Next on the list is V butt joint. Next on the list is V butt joint. Now when the thickness is in between 5 and 20 mm, okay, when the thickness is in between 5 mm and 20 mm, then we bevel the edges of the plate. We bevel the edges of the plate to form a V shape. And since this V shape is formed, that's why we are calling this type of joint as V butt joint. Now, in case of V butt joint, we only do the welding from one side. We are going to do the welding from this side only. Okay, we are only going to do the welding from this side. Similarly, in case of square butt joint, we also do the welding from one side. So this type of butt joint, which is square butt joint, is used when the thickness of the plate is less than 5 mm. V butt joint is used when the thickness of the plate is between 5 and 20 mm. And in case of V joint, what we do, we bevel the edges to form a V shape. Next in the list is your U butt joint. When the thickness is more than 20 mm, the edges of the two plates are machined to form a U shape. To form a U shape. That's why we call this type of butt joint as U butt joint. Now, obviously, the thickness is in case of the thickness of the plate in case of U butt joint is more than V butt joint and square butt joint, but also the reliability of U butt joint is higher than the V butt joint and square butt joint. Now, the fourth figure shows you a double V butt joint. And in case of a U butt joint also, we do welding from one side. Okay, we do welding from one side. Now, in case of double V butt joint, we bevel the edges such that a V is formed at the top as well as a V is formed from the bottom of the plate. Now, this type of butt joint is used when the thickness of the plate is more than 30 mm. So, if the thickness of the plate is more than 30 mm, we will go for double V butt joint, and we bevel the edges of the plate in such a manner that it forms a V from the top of the plate as well as a V at the bottom of the plate. Now, in this case, in this particular case, in case of double V butt joint, we do the welding from the top of the plate as well as from the bottom of the plate. We are going to do the welding from both sides. Because if we do the welding only from one side, then this molten material will not be settled properly at the bottom, and the strength of the of this welded joint will be much lower when compared to the straight calculated analytics. That's why we do that's why we do the welding from both the sides, such that the molten metal reaches or the molten metal fills this gap properly. Now the last type of V joint or the last type of butt joint is a V joint with backing strip. Now we use this V joint with backing strip only in the cases where the welding from both the sides are not possible. Where the welding from both the sides are not possible, and obviously this is used only for plates which are thicker than 30 mm. If the thickness of the plate is greater than 30 mm, and if we cannot do the welding from both sides, then only we will go for V joint with a backing strip. In this case, what we do, we put a backing strip over here so that the molten metal does not flow out of this gap. That's why the purpose of this backing strip is to prevent the overflow of the molten metal from this gap. And we will obviously be doing the welding from this side only, because there is no scope of doing the welding from bottom side. So as I told you, the purpose of the backing strip is to use the purpose of the backing strip is to avoid the leakage of the molten metal from the other side. There are two types of backing strips used for this purpose. The first one is permanent steel backing strip, and the second one is removable copper backing strip. So if you want to remove the backing strip, you can use a copper plate, and if you want a non-removable or a permanent backing strip, you can use a steel strip. Now another thing to note here is that the reliability of the double V butt joint is higher when compared to any other joint. It is even higher than V joint with a backing strip. So in case of reliability, this is the double V butt joint is the most reliable joint. And obviously it is only used when the thickness of the plate is greater than 30 mm. When the thickness of the plate is greater than 30 mm. So this was all about the classification of the butt joint, and you can choose an appropriate butt joint as per the application or as per the thickness of the plate and the reliability needed in the structure. Now let's talk about the another type of welded joint, which is your fillet joint. Okay. So in case we also call the fillet joint as a lap joint. So a fillet joint or a lap joint is a joint in which you keep the plate or the structure one over another. A part of a part of a plate is overlapping a part of another plate, and the welding is done along the edges. That type of welded joint is known as a fillet joint. In this figure, you can see here that a plate, or rather, let me change the color of the pen. Or rather, a part of the plate, a part of one plate, is overlapping a part of another. Okay. So when both the structures are overlapping, this type of joint is known. This type of weld is known as fillet weld or a lap weld. Now it consists of approximately, you can see it, from this figure, this is an enlarged view of this part, this figure is an enlarged view of this part. You can see that it is approximately a right angle triangular cross section. Okay? The cross section of the weld is approximately a right angle triangle. And you need not to worry about this parameter. In the coming slides, you will know that y this c is equal to 0.707 of s. S is the distance, S is this distance. Okay? And this is a right angle isosceles triangle. That means this length is equal to this length. This part of the triangle is equal to this part of the triangle. Now from this figure you can see that there are two types of cross section for the fillet weld. This is your normal cross section or the right angle isosceles triangle cross section, and the second one is your convex cross section. This figure B is showing here convex cross section. This is your convex cross. Now the normal weld consists of an isosceles right angle triangle, whereas this is your right angle isosceles triangle, and this is your convex fillet or lap weld. Now a convex weld requires more filler material, which is very much evident from this figure. You can see that it requires more filler material and labor when compared to the normal cross section. And there is more stress concentration in case of convex weld when compared to the triangular cross section weld. So this type of cross section needs more filler material, it needs more labor, and it even has more stress concentration. So these are the three disadvantages of convex cross section weld. The first one is it requires more filler material, which obviously is going to increase the cost. The second disadvantage is it requires more labor, which again is going to increase the cost. And the third and the most important disadvantage is that it has the stress concentration is high in case of convex cross section when compared to the normal cross section. That means that the strength of this cross section is less than the strength of this cross section. Therefore, always we prefer normal weld over convex. We are always going to prefer this type of weld over this weld. And in the due course of this lecture and the due course of this course, we will always be using this type of cross section for all the designers, all types of fillet weld, be it a parallel fillet weld or a transverse fillet. Okay. Now, a fillet weld is also divided into two categories. The first is transverse fillet weld, and the second one is your parallel fillet weld. Okay. Again, I have already told you, I have already explained you both types of fillet welds in the first lecture. But let's see once again what is a transverse fillet weld and a parallel fillet. Now this figure over here shows you a transverse fillet weld. This is a single transverse fillet weld and a double transverse fillet weld. Now this is the direction of this is your single transverse and this is your double transverse. This is the direction of your weld. Okay, this is the direction of your weld. Now, when the applied load on the structure is perpendicular to the direction of the weld, in both the cases you can see that the applied load on the structure is perpendicular to the direction of the weld. This type of weld is known as transverse fillet weld. This type of joint is known as transverse fillet weld. Now, in this case, you can see that a plate 1 is overlapping the second plate, and the welding is done only at one edge. Okay? We haven't done the welding at the second edge. There is no welding at the second edge. So these type of transverse fillet weld are known as single transverse fillet weld, and the single transverse fillet welds are generally not preferred because of the obvious reason that the edge at which the welding is not done, uh, which is this edge in our case, this is the edge where welding is not done. So this edge will warp out very easily. With the application of little force only, this edge will warp out and break this weld. So the strength of the single transverse fillet weld is very low when compared to a double transverse fillet weld. What is a double transverse fillet weld? Double transverse fillet weld is a transverse fillet weld where the welding is done on both the edges. This is your first edge where the welding is done, and this is your second edge where your welding is done. So single transverse fillet joint or weld is not preferred because the edge of the plate which is not welded can warp out of the shape and will break this welded edge or the welded connection. Because of which the strength in case of single transverse fillet weld is low when compared to the transverse fillet weld. Now, another type of fillet weld is parallel fillet weld. This figure shown over here is an example of double parallel fillet weld, where you can see that this is the direction of the weld, this is the direction of the weld too. Now, in case of parallel fillet weld, the applied load, the load which is applied on the structure is parallel with the direction of the weld. You can see that these two lines are parallel. Similarly, these two lines are parallel. So, in case of a parallel fillet weld, the direction of the applied load is parallel to the direction of the weld. Whereas in case of transverse fillet weld, the direction of the load is perpendicular to the direction of the weld. So these are the two types of transverse fillet weld, and in the coming lecture or in the next lecture, we will see how to design and analyze a butt joint, a parallel fillet weld, and a transverse fillet weld. The figure over here shows you some other types of welded connection. This one is a T-joint, this one is a corner joint, and this one is an edge joint. This is just for your information, and we are not going to design these types of joints. We are only going to design a butt joint, and the second one is your parallel fillet weld, and the last one will be your transverse fillet weld. Yeah. A corner joint is a joint between two components which are at right angles to each other in the form of an angle. You can see that they are at right angles to each other. This type of joint is known as a corner joint. Now, an edge joint is a joint between the edges of two or more parallel components. You can see that this plate is parallel to this plate, and there is a joint where these two components are parallel to each other. And a T-joint is a joint where one plate is kept perpendicular to the other plate. We can also design this type of welded connection by treating them as a fillet joint, because this plate is overlapping this plate, so this can be treated as a fillet joint. Now, these joints are not important from the design point of view because they are used for thin plates which are subjected to light load. Okay, these types of joints are always designed for thin plates which are subjected to light load. And the butt joint or the fillet weld which we are going to design might be subjected to heavy load. That's why we have only considered those joints for the design purpose. So this was all about this lecture. I will end this lecture over here. In case you have any doubt, you can comment on this lecture, or you can WhatsApp me using your WhatsApp group, or you can in that live class also you can ask me any doubt. Okay then, thank you for this for listening this lecture, and I see you in the next one.